Well, good afternoon. We welcome you to today's webinar, where my colleagues and I will introduce how the Esri platform can be applied to meteorological data analysis, visualization, and sharing of the information products that can be generated when utilizing a fully enabled WebGIS. My name is Jeff Donzi. I lead our weather and climate community efforts for Esri, as well as manage our relationship with the NOAA National Weather Service. I'm joined today by two members of Esri's product team from our headquarters in Redlands, California. Dan Pasut, who is our content lead for our Living Atlas of the World. Dan has a great deal of experience of working with atmospheric data. And Kevin Butler, a senior product engineer with Esri, who has extensive background working on the spatial analysis area of Esri's platform. After a brief introduction, we'll quickly move into the technical portion of the agenda led by Dan and Kevin. This agenda includes brief presentations and demonstrations on the resources, tools, and data that have been developed by Esri for this community. During this webcast, we'll keep everyone on audio mute during the session, but you can ask questions by entering them into the chat window on the webinar control panel. We'll endeavor to take breaks for questions during the session, as well as have a specific question and answer period at the end of the session. And by the way, this webinar is being recorded and will be made available on our Sciences Weather and Climate website. Esri has been working hard to ensure our products support the sciences and atmospheric community. You can see that they're representative of a wide range of disciplines and areas. As a result, have strengthened the scientific foundation for Esri software and services. We continue to strive to understand the requirements of meteorological agencies and organizations so that our products can meet the high demand for weather information that we're seeing globally. As a part of the process, Esri staff, including our chief scientists, participate in international scientific community on various boards, councils, research projects, and industry conferences. Through these involvements, we learn and expand our products' capabilities. We would also welcome your feedback from what you see from today's webinar. Through our work in this field, we are finding that ArcGIS can serve as this sort of valuable connection between the organizations that, like yours, like many of yours, that produce meteorological data and analysis, and then the organizations that are the consumers of this information that need it to evaluate impacts on their businesses, their missions. These include utilities, local governments, insurance, and other areas of the global economy. Esri's own organizational structure provides us the ability to establish that connection between the primary consumers of weather information and meteorological agencies. Our teams are represented here on the slide, are working in many sectors that are consumers of weather and climate information. The role of GIS is so unique in that it provides both the end user environments that you will see today, as well as the development tools for organizations to develop their own specific workflows or end user applications. Again, we'll be showing you some of those in a few minutes. Esri is also expanding our capabilities to support big data management, analysis, and dissemination that are important to meteorological organizations. These also include emerging capabilities with artificial intelligence and machine learning to identify patterns in the data. To serve our user community, we have also a comprehensive online sciences portfolio that is one of its initiatives, showcases some of the leading weather and climate organizations that we work with and other resources, both use cases, projects, and products. These include commercial weather providers as well as some of our list of partners that you can see here, like the Weather Company, DTN, Keysters. We also have our Living Atlas of the World, and while you may think of us as mainly a software and data analytics company, we also specialize in providing access to curated data or content from our customer community, in addition to Esri hosted content that you can find here in the Living Atlas. This is one of the largest collections of global geographic content available. thousands of ready-to-use data sets in GIS-ready format, maps, apps, but also authoritative sources from thousands of contributors, such as the National Weather Service and the European Environment Agency as examples. We'd also really welcome additional data to be contributed from European Met agencies in the future. The Esri platform, including the rich authoritative data available in the Living Atlas, is another way we provide that connection between many of you, the producers of the information, and consumers of weather and climate data and analytics. We'll show you many examples in the next few minutes here, which will be shown by Dan and Kevin. So with that, I'll turn it over to Dan to kick off the first presentation. Dan?
All right, so as Jeff mentioned, we're going to be going through a series of demos today. We've laid them out for you here. There's a total of 16, so we're going to go pretty quick through these, Kevin and I, but we'll be covering a couple major topic areas that we think are really important to the meteorological community. One is acquiring data, two is managing that vast amount of data, three is visualizing it, of course, which is such a common topic in meteorology. Three is going deeper than the visualization and analyzing it. And then the fifth one is sharing that, which we think is critical, since so much of meteorology, and especially severe weather, is all about sharing information to areas and people in need. So let's get started. We're gonna begin with acquiring meteorological data. So we all know how vast and complex meteorological data can be, whether it is the enormous models that are being developed, multiple times a day, the outputs of those with hundreds of variables, satellite data that is getting more and more complex and higher resolution, and then in situ and point data that's coming from a variety of sources. This is big data. And so the Esri platform has been working very hard to be able to bring in natively any of that type of data that we find throughout the meteorological community. So we're going to start off with a demo on gridded files, which are typically one of the most common formats. So whether that is a satellite data product or a model or some kind of analysis that is gridded, you'll see that our platform, it's handling all the major types. So GeoTIFF, GRIB, NetCDF, that is CF compliant. I must stress that things have to be CF compliant. You can't just have any random flavor of NetCDF that you want. Same thing with HDF. And a new format that we've been developing, which is cloud raster format, which is a lot more efficient in storing of multidimensional data, especially with time, because we can put a transpose function in that, which allows you to access that time component a lot more efficiently. And of course, all of the tabular point line poly data that GIS is known for. So we're going to start. We'll be doing all of our demos in ArcGIS Pro. And so we highly encourage anybody who's working, especially in meteorological fields, to be doing that in ArcGIS Pro, because that has really been advanced and has a lot more capabilities for this field, this sector, than ArcMap. So let's add some grid data. So we're going to make sure that we're on the map panel, and we'll go to the multidimensional raster layer, where all we have to do is browse for our file. Here's a grid file. And it's going to read it. It's going to show us all the different variables that are in the file. I'm going to pick this gust layer. We're going to read it and display it. So this is a single time step. I just have this one pre-configured with a color palette for myself, and we can click on the values and we can get the velocity directly out of the raster. So we'll see that this is a common pattern. We did that step with GRIB, but for any of those other multidimensional formats that we talked in the previous slide about, it would be the same basic step. So we can go to another demo really quickly here. I did the same thing of adding multidimensional data, or we can do it through another tool in the geoprocessing, make multidimensional raster layer. Nice thing about doing it in this way is this area allows you to script it in Python. But here we see Sentinel-5P, nitrogen dioxide data coming, and we can see that NO2 plume right over the Moscow region. That's typically associated with greenhouse gas combustion or fossil fuel combustion. All right. So again, all of we can access multidimensional data, those single time step multidimensional files, or they might have time component into it, but we don't have to do multiple files. It's a single file there. So we can do it either from the map tab or the analysis tab. The analysis tool, which is available, the make multidimensional raster layer, again, is available as a scripted Python utility. So I think Kevin is going to walk us through connecting to cloud data.
Thanks, Dan. We're seeing increasingly that our customers need to and want to store massive collections of data in the cloud. This seems to be the new pattern, and we've made some recent changes to ArcGIS Pro that allow you to seamlessly connect to a wide variety of cloud storage resources. For me, the pattern had been in the past that I had to install something like S3 browser. I go up to a cloud store and download that data to my local machine, and that could be very time consuming. So what we've tried to do is integrate access to these cloud storage resources directly into ArcGIS Pro. The example we'd like to use today is actually data from the UK Met Office from the informatics lab. And they actually released a very rich set of data to help people look for these relationships between COVID-19 and environmental factors. And so we'll show in this next demo how to actually access that data. They provided all of the information that I needed in a publicly available blog. And so any ArcGIS user could use that information from the blog to connect to that rich resource. So let's hop into the demo. So in this instance, I'll just go to the Insert menu. I want to put in a new connection to cloud storage. Just specify a meaningful name for me for that connection file so that I can reuse it, and I only have to create this connection file once. You can see we support a wide variety of service providers. Met Office provided it via Azure. In the blog, they provided the bucket or container name, and that's COVID-19 response. And they also provided the public account name for us to access that data. I'll change the Arc Deep Crawl so I see all of that data that's there. That just allows us to dig a little deeper into the directories. And now it's going out and it's connecting to that cloud store, and I can see the rich set of data that UK Met provides here. Just a little bit of network latency there, and you can see the variety of data that they provided. Now what I'm going to do is actually use one of those geoprocessing tools that Dan talked about, make multidimensional raster layer, point up to that cloud data store, and now it just appears as if this data is on my local machine. I think we'll go to maximum temperature and then pick any one of these daily files. It looks like January 1st there. And let me get this tool running. Now we are streaming global data across the web here. And so I'll get the tool running. One of the advantages of using the Make Multidimensional Raster Layer tool is that you can see there that variables of air temperature. If your cloud data contained multiple variables, you could just select one of them or bring them all in at one time. We also, this data looks to be global with an extent from 0 to 360, but this tool allows you to subset that. So you can you can easily bring this down. Now we'll take just a second for this data to come in. I am streaming a global data set. I probably should have subsetted it a bit there. So in addition to the spatial subsetting that you can do via this extent parameter, you also can do dimensional subsetting. So if this data set had multiple time periods in it, you could just select the January data if you wanted to do that. So let's give this another second in order to load the data. It's just about ready to refresh here. And there we go. It did indeed update. And you can see the spinning in the bottom right there. It's just drawing the data right now. One more second for this to load. So as Dan indicated, there's multiple ways in order to bring in these multidimensional rasters. Here I'm using a geoprocessing tool. You can do the same thing by adding it through the menus. And I'm just going to click on the map and identify an area so that we can see that the temperature values really are coming through in this data. And I think that's fine. I think we'll move to the next demo, Dan.
Oh, sorry. All right, so the next thing that we're going to show is another form of cloud stored data, and that's going to be something that Jeff mentioned earlier, which was Living Atlas. So Living Atlas is a part of the ArcGIS platform. It's not a storage per se, but it's a way for you to make your data available through the ArcGIS platform in a centralized metadata repository. So you nominate data to it, we review it, we curate it, and then the access points to that data go into the ArcGIS platform, whether they are locally served by you or in a cloud storage or whatever it happens to be. And so we already have, close to 10,000 layers in Living Atlas, many of which are GIS, they're all GIS ready, many are analytical in nature. So they're rasters with the actual point values or features with rich data, attributes. And as far as the weather community, we have a lot of contributions from NOAA and NASA, NCAR, IBM, the weather company, and from the Netherlands, the Climate Effects Atlas has contributed many of their layers into it, which really provides a rich resource for analysis in those regions. So here we go, accessing Living Atlas is as easy as going to your portal tab and clicking on Living Atlas, and then you just search. Search is sometimes easier in the website, so you can really see all there is to offer, but once you find something, you just drag it and drop it into your project. Here I have global weather stations. We get this information directly from NOAA, but it's all the global METARs. And so we can open up the attributes, and this is coming in real time as the stations update, so we can see all the different, I think there's usually 12 or so variables associated with each one of the stations. And we're symbolizing on winds, but you could symbolize by any of those things. So next I'm going to go in and type GeoGlows, which is a new weather stream forecast model from ECWF that we've been working on providing through Living Atlas to our users. So this is a 6-day forecast. We're running the 6-day forecast part of it with Brigham Young University and Microsoft. But we can see here river flows into the future, and we're symbolizing them here based on their exceedance. But you could symbolize things based on other attributes. So this is a new offering again that we're partnering with Geo and ECMWF to provide in Living Atlas. But this is just an example of one of the types of forecast data that could be made available as a streaming service, a streaming data service, which is quite exciting. Many of the products in Living Atlas, you work on through a remote connection, but you can also download if you needed a local copy. If you're not going to be connected to the internet, you could copy the features or copy the rasters into a local or cloud storage. So Kevin, I think is going to take OpenDAP.
Great, thanks, Dan. As Dan showed, we've got a rich ability to bring in data from your local machine, supporting a wide variety of formats, particularly some of those scientific data formats such as HDF, GRIB, and NetCDF that are so important to the meteorological community. And we have access directly integrated to Pro to the Living Atlas to bring in that rich set of data, but there's many other data providers out there that also have put their data up in a server environment. And one of those environments that we use a lot in the United States is Threads. This is an open source web server that is designed to deliver a lot of different types of data and to really homogenize that data so that it can be streamed easily across the web. And the protocol that they use in order to do that is called OpenDAP. So an open data access protocol. And we've built support for OpenDAP servers for the OpenDAP protocol into ArcGIS Pro. So let's just jump directly into the demo. Okay, we've got a couple ways of accessing OpenDAP data. One of them is through a geoprocessing tool, which is Make OpenDAP Raster Layer. OpenDAP has accessed the data through a URL. I've pasted that URL in. I'm not interested in the climatology bounds. I want to look at precipitation. You can see it automatically found the spatial variables associated and adjusted the extent. So again, I am streaming global data across here, so I'll get this tool running, and that precipitation layer is starting to draw now. So let's go back and look at another way to get OpenDAP data. No, in this instance, I think what I'll do is, this is multidimensional data. So we're looking at the first time slice here of this data. And so the Select by Dimension tool will allow me to select the dimension of time and then change the current slice that I'm seeing from anyone that's listed here in this list. So we do have another way of actually accessing OpenDAP, and that's by specifying the URL directly into that tool, Make Multidimensional Raster Layer. So a few of our tools will actually take the URL from OpenDAP directly as the input parameter. And in this case, again, I'm interested in precipitation. This looks like daily data of long-term means of total precipitation. Again, this is global, going from 0 through 360. We'll get this to update. It's streaming that data across the web now and drawing that layer. Again, I could have done spatial constraints here or temporal constraints. Let's open up the properties of that layer so that we can actually see that it is multidimensional. It's precipitation. There are 365 slices or time steps in the data. And if I scroll down a bit, you can see that it is daily. It's regular daily. And it looks like it goes from 1981 forward. You also see that the time slider is automatically enabled on the map at the top. So the symbology is not great on this layer coming in. So I've symbolized it, and again, we can see that same exact data just brought in through the Make Multidimensional Raster Layer tool. Let me identify just to show we can query this. And one of the nice things about these scientific data formats is this is precipitation, and I can see that it's actually in millimeters. So a very convenient way in order to bring this data into ArcGIS Pro. So we've shown the ArcGIS Pro interface pretty extensively so far, and given a couple examples of how you can access data remotely through the user interface. But we know that you do a lot of your work, not necessarily through the GUI, but through scripting. And we do have the ability to also bring in these data through scripting languages. Python is our preferred scripting language for the Esri platform, and any of the tools that we've shown, the Make OpenDAP raster layer or the Make Multidimensional Raster Layer tool, all have Python equivalents. We have well over 1,500 analytical tools in our toolbox, and all of those have an equivalent Python interface to them. So what I'd like to show today is the extensibility of the platform. We've shown you our tools, but our colleagues at Unidata have produced a nice Python library called Siphon, which is designed specifically to acquire meteorological and climatological data from the web. And I want to actually show this in a notebook that's actually embedded in ArcGIS Pro. So let's hop right into the demo. So you'll see here I'm still in ArcGIS Pro, but we see the very familiar Jupyter Notebook interface. And the advantage of having this within the ArcGIS Pro interface is that I can now interact from this notebook directly from my table of contents and back and forth. So it makes it quite easy. So this demo is courtesy of our colleagues at Unidata, and what I'm going to do is query a Threads data server that's offering some radar data, something our customers often ask for. So just a little housekeeping here to make sure my plots plot in line, doing some imports, and then I'm going to query the Threads data server here to see what data sets that it has available. It looks like it's got a series of NextRad data, both level 2 and level 3 data. And now I'm going to point to the appropriate radar server here in order to get that data set. And these are the variables that are available within that data set. Next, what I'm going to do is create a new query object so that I can actually request that data. And I'm going to request FTG, that's Denver, Colorado for us. And then this module has utilities to help me create that query. I've created the query, validated it. Now I'm actually going to get the catalog to see which data sets are there. And that's a typical radar format that we're looking at here. It's a level 3 for Denver. And then I'm going to ask, what are the URLs that I need in order to access that data? This is much easier than me trying to construct those URLs by hand. You can see that it supports the OpenDAP protocol, but it also supports this remote command protocol. And that's what I think I'll use today in order to access that data. So now I actually have the data in a Python object. I'm going to now get the range and the azimuth in the reflectivity there, and then I'll convert those to from polar to Cartesian, and then use the standard matplotlib in order to just plot those results. So we can see not a very exciting day in Denver here, but this is the very familiar interface of Jupyter Notebooks that I suspect that many of you work with. It's embedded directly into Pro, and so you can access remote data in that way. So back to you, Dan.
All right, thanks, Kevin. So, we mentioned before that that ArcGIS Pro is really an effective way, and the platform is an effective way to also manage your data. A lot of times in meteorology, we have a lot of different ways in which data are served. It could be a single time step for each model output with multiple variables in there, and you need to consolidate that into a way so you can seamlessly go across time. The time could be all in one file, and now we need to go get multiple files with multiple variables in them and then consolidate them so we can analyze across. So it's pretty complex stuff that we have to deal with. So we've done a lot to add in some simple utilities to help with some of that data management. And I should also say, sometimes you just don't need all that global data, and maybe subsetting or getting just a portion of that out for your analysis is what you need. What we're going to show today in a demo is it's probably one of the utilities that I use the most, and that's creating a mosaic, a multi-dimensional mosaic. And mosaic is the term that we use as a container that in our file geodatabase that organizes all of these large rasters with multiple either variables, time steps, dimensions of elevation, whatever it happens to be. And the great thing about mosaics is it's just a way to reference where files are located. You don't have to have all those files locally. Some could be on a cloud storage, some could be local, some could be of different areas. And the mosaic is a way in which the platform knows how to bring the appropriate data in at the appropriate time and space. One of the other great things is when we use web services, image services for rasters, the most effective way to do that is through a mosaic, because when you have to update your image service, your web service with your raster data, all you have to do is update the mosaic, which is the reference to where the new data is located. You don't have to completely upload and delete the old data. All you have to do is swap where the data or the mosaic is pointing to, so updating the mosaic. So it becomes really a much more efficient way or workflow for updating your services. So here we go. I'm just going to bring in some model data from over Alaska. We can see we're adding rasters to a mosaic. So I have a bunch of her grid data. You can see all the different formats that the mosaic supports. I've loaded them in or pointed to where they are located, but just like before, we're just going to peruse the different variables that are available from the grid time series. And I'm going to take temperature at surface. One thing we like to do is calculate statistics on it as we run the mosaic. It's just going to run for a minute or so. It depends on how large your raster data set is. So now it is updating the information associated with the mosaic. So I can go in there now and open it up. And here we have temperature at surface. And we can see also the time component is now there. So we are reading seamlessly across all of those different files that I added into the mosaic. And what we'll see is that not only can you visualize this data, but you can also analyze the data across the mosaic. We'll get into some of that analysis in that analysis section that we have. One exciting thing that came out in our 2.5 version of ArcGIS Pro was the multidimensional ribbon. So a new ribbon at the very top that has a bunch of common tools that you use for managing and analyzing data. So getting back to that management process. So here we go back. Here's the, if you're clicked on your multidimensional layer, the ribbon will show up. And we can see on that we have some of the things that we'll cover later, like temporal profiles and summary statistics, and some analysis capabilities, either in summary statistics or some of the newer time series tools that we'll see here that we'll get to in a couple minutes. But we have a whole new data management section. So here we have the tool, a quick step to make the multidimensional raster layer that we've been showing you, but also subset. So maybe you are starting, or somebody created this mosaic and you don't need the whole thing, or you just need to export something. You need to work with one component of it, that you can run the subset of your mosaic or of your multidimensional file and just get out what you need from it. So again, we're going, in the beginning, we went from little files to a larger compilation, and now we can also go in reverse. You are given something that's very large in nature, and you need to simplify it. So we can do both with the platform. All right, Kevin, you're taking this section?
Sure. So we've shown a lot about data and ways to acquire that data both locally and remotely, and then to manage massive collections of data through the Mosaic data set. But we don't just collect data for, for the benefit of collecting data. We need to do something with that. So these next two sections will talk about kind of where I think the strengths of the Esri platform really shine, and that's in visualizing and analyzing data. And really, meteorological data presents some unique challenges for visualization. It is inherently multidimensional. We're always looking at multiple time slices or different altitudes or pressure levels. This is also a challenge in oceanography as we're looking at various depths. And so we've tried to create some tools that we hope you find useful that can allow you to actually visualize this three-dimensional or four-dimensional data. But even beyond just visualization, to see patterns and trends and outliers and find anomalies. And we do that in a variety of ways, and we'll show you just a couple of those today. So let's hop into the demo. So the data that I'm using today is from the University of Delaware, and I'm going to create a temporal profile here. So you can see here, I'll just look at this layer. This looks like long-term monthly mean of temperature. And it has 12 time slices in it. So I'm going to create a special chart type called the temporal profile. And what this allows me to do is to select any particular location and then drill down through all 12 of those time slices. All of our multidimensional data has a field for standard time. I'm going to select a point here to define my area of interest. Let me make a little room on the map here so that we can actually, let's just zoom to Europe here. Then I'm going to simply click on the map at any location, and it automatically generates that temporal profile. So it drilled down through all 12 slices and created the chart. I can select multiple locations here. Let's go a little farther south. We can see that we have full control over that symbology, and I can actually label these locations. I don't only have to choose a point, I can actually also draw a lasso or a rectangle. And then at that point, I'm not drilling down just through one pixel at a time, but through all of the pixels within that rectangle and aggregating the temperature, getting the mean temperature at those locations. So a very quick way to introspect this multi-dimensional data, okay? So that was the data clock. We have other temporal chart types. The data that I'll use, we've been showing a lot of raster data. I want to show that we actually do also support time when it's applied to point data or line data. And so the data set I'm using here is NOAA's Severe Storms database. I understand that you have something equivalent for the EU. And this is the occurrence of severe storms or other significant weather that really has the possibility of causing loss of life or injury or property. So a very important data set for us. So let's hop into the demo. You can see here that this is not a very informative map. It's very difficult to see any spatial patterns, and it's really hard to see any kind of temporal patterns at this point. So again, I can create various types of charts, but I want to make sure that indeed, yes, we are simply looking at hail in this data set. The data set has a wide variety of severe event types. So let's go ahead and create a chart. And in this instance, I want to create a data clock. I want to explore when severe hail events occur most frequently, at least in the continental United States. In this, the rings of this chart represent years, the wedges represent months. In this case, I'm not going to do any aggregation. I'm just going to count the number of severe weather events that are there. You can see that May and June in the US have the most severe hail events. And it looks like we had some particularly bad years in 2007 and 2009. We give you complete control over how this chart is displayed, and I'm having a little trouble seeing those sectors and wedges, so I'll draw some lines in between those to make it a little clearer. All of these charts can be exported out to a variety of formats for inclusion in reports, and these charts can be included in layouts or reports within ArcGIS Pro, and these can be automated. What I'm showing here is that the charts are linked to the map, a very important feature. So I can see that particular bad May. I want to see exactly where on the map, highlighted in blue there, where those severe storm events occurred. And I'm seeing some of those anomalous events in February. And those look like those are restricted to the Southeast US. So I'll clear that selection. Now we do have other chart types also. That data clock has been quite popular, but we've also had lots of requests for something called a calendar heat chart. This is a little more consumable to the general public. Again, I'll choose that date. And this is showing by year, by month, and day of the month when the severe hail events actually occur. So we can see in June, and it looks like around the 7th to the 10th of June there were some particularly bad days for hail events in the US. So just another view of the data temporarily, but we've added these time-specific chart types really to support the important requests that we've gotten from this community. Well, while we've worked really hard to add these additional chart types into ArcGIS Pro, we know that there are some very unique but yet critical types of charts and plots that you need in the meteorological community that probably just really aren't going to be that useful to a general GIS audience. So one of the nice things about the Esri platform is that it is highly extensible. We have the ability to include other Python modules in order to do things that we haven't built into the core of the software. And I want to show you an example of that with a very nice Python package called MetPy, of course, designed specifically for the meteorological community that comes from our colleagues at Unidata. And again, I'll show this in the notebook setting. So let's hop right into the demo. So I want to produce a simple sounding chart. And again, we're in notebook. So let me just do some matplotlib magic here in order to make sure my plots display in line. Some housekeeping for some imports. Let me just set the size of my charts there. And again, I'm acquiring some upper air data remotely using Siphon. So here I'll actually get the variables. I'll generate my skew-t plot there with just some pretty standard matplotlib plotting. And we can see that we've got, you know, a pretty interesting chart here already with wind barbs. And this is quite useful. So again, these can be exported. And really, there's many other possibilities within this MetPy library. Well, great. Let's move on to analysis. Visualization is an important step, but we go beyond this idea of simple visualizations. We actually have a very large set of analytical tools that allow you to operate on points, on lines, on raster data sets. And as Dan indicated, we have some specific tools that allow you to do multidimensional analysis for doing things like subsetting, for anomaly detection, and things like that. So Dan, I think you're going to hop in and show us how we can do the probably the most important first step of any good analysis, which is actually doing some descriptive statistics.
Yeah, thanks, Kevin. So we've done a lot of updating of some of these, you know, kind of basic tools that also handle multidimensional analysis. And sometimes you'll see that as an option to process multidimensionally. So make sure that you're checking for some of these if you've been using them before, but maybe on an older version of the software. So we have a couple new tools that we're going to cover as well. That are really great for meteorological and climatological applications. And those are for aggregating files for calculating anomalies on the fly, doing trend and prediction analysis as well as some space-time pattern mining. So here we go. I have HiCom coming in from the Living Atlas. And what we would typically do is go into our geoprocessing and run cell statistics by, you know, configuring this menu here with all of our different options and then running that menu. But you would have to know to search for cell statistics and go through that workflow. What we've upgraded again is you can click on the layer, multidimensional pops up, and the summary statistics are right there. So now you can click on one of those options, whether it's the min, mean, whatever, and it's automatically going to process the output. So we can see here, I did a T-min across the time series of HiCom, and we can get the resulting T-min. So this would work if it was a Mosaic that was on your local computer or some of the other remote connections that we've talked about before. So that's great. That's you know, some of the first things that we always do is look at min, max, and means, right? We've just made accessing that and processing it that much easier. And again, these are part of the spatial analysis toolbox, so they are scriptable in Python. They can be called if that's your preferred way to do it. So next, I'm going to go on to the multidimensional toolbox again. Here I have GPCP, the Global Precipitation Climatology Project. So this is 1979 to current monthly precip data. But what I may want to look at is, instead of the actual amounts, the anomaly of it. And so all we have to do is point to the layer. It's already configured. We're going to do difference from the mean, but there's some other options that you have for calculating your anomaly. Percent of the mean, you know, see the options there. And what is the interval? Do we want it based on a monthly or yearly anomaly, whatever it happens to be? I'm going to do monthly because it's monthly data, and I want to see the monthly anomaly. So all we have to do is run that tool. And we get the output as an aligned layer in time. So for every time step of precip, we can see the time step in anomaly here, and I'm going to go get my swipe tool. On the wrong layer. And here we go. We can see how the patterns of precip match with the patterns of the anomaly. So again, that is just one of the many new tools that are available in the multidimensional analysis tab. But these are incredibly useful for me. And in our next version of Pro that's releasing in a couple months, there's an upgrade to the anomaly tool so that you can set the range of time that you want your climatology or your comparison period to be set from, which is really exciting. So if you have a standard climatology that's 1981 to 2010 or whatever that you're using, you could specify that in the tool settings. All right, Kevin, take it away.
Thanks, Dan. So we've shown some pretty straightforward analyses, kind of where you should start any good analysis, looking at your data, doing some summary statistics, making sure that you don't have outliers or you understand why you would have outliers in your data. But what I want to show next is kind of more of a workflow where we've used a series of tools in ArcGIS Pro in order to objectively derive some alternate climate zones for the US. Now, I'll say up front that this was intended to be didactic. You know, I'm not claiming that we've discovered the true and new novel climate zones for the US. It was really there as a teaching tool to help people that, have a stronger footing in meteorology to be able to explore these data. And I chose this example because it shows some of the unique power of the ArcGIS platform is that we have algorithms that are spatially explicit. So in this case, I'm doing clustering, which is a common thing to do with meteorological data, but the clusters that I'm creating are spatially constrained. Meaning you can't be a member of that cluster unless you're adjacent in space. So it creates, so I think some really interesting opportunities for creating, climate zones, homogeneous meteorological regions. So let's hop into the demo. Great, so I took one of those. Let's actually look at, I think first we'll look at the original climate classification that so many people are familiar with. If I just get my mouse over to, there we go. What we're looking at here is the Köppen climate classification just clipped to the United States. At least in the United States, we're used to seeing this from elementary school on. And frankly, it was never very informative to me. This is derived a lot by expert opinion. And I was just wondering if we could produce a classification that was a little more granular spatially and objectively derived. So I took some long-term monthly mean data for temperature and precipitation from the North American Regional Reanalysis Climate Model. I converted that to points. And you can see, because this particular tool that I'm using only accepts points or polygons, and I have long-term monthly means for 12 months for temperature and long-term monthly means for precipitation for 12 months. I'm looking at 24 variables and grouping points together that have similar values across those 24 variables. And that tool is aptly named Spatially Constrained Multivariate Clustering. And you can see that it groups things that are similar together, but only if they're adjacent, at least in this instance, adjacent in space. So I've run that tool already. It does take a few minutes to run given that number of points. We have some features built into the tool that automatically help you determine the optimal number of clusters. Clustering is both an art and a science, and it's challenging to find the optimal number. And these climate regions look somewhat reasonable to me. I think I see Texas split where I expect, California. I've used some other cartographic tools in order to clean those up, smooth some of the edges, and produce what I think is a much more cartographically pleasing example of potential new climate zones for the continental United States. This workflow is easily replicable anywhere in the world, really for any set of data to create homogeneous regions. All right, Dan, concerned about time here. I think that we should just go ahead and jump directly into sharing. For that demo that we had scheduled for building climatologies, we'll put the link to a blog that outlines that workflow and the output maps in the slides when we send those out. So back to you, Dan.
All right. So, as I was saying at the beginning, sharing information is pretty critical in meteorological disciplines, whether that is with a colleague who is doing a different part of the workflow or the analysis. Maybe you're processing the data, they're doing the actual forecast from it, or it's getting it to the public. One of the great things about the platform in ArcGIS Pro is it's really meant to break down the lines between the things that are in the cloud and the things that are on your computer, which inherently makes sharing that much easier. So it could be publishing an updated layer to your own particular portal that your internal organization has access to, or it could be sharing it out to the public as a layer or as an app that they can more readily consume. So I have some data here that I want to share. So typically you go and you might do sharing as one of these, as a layer or a package, but you can also share or overwrite a web layer. If you were connected to an image server, that would also be an option. But in the share panel, here we have so many more options. I'm going to choose a web map. So I'm going to publish what our analysis here, and this is NOAA's global temperature anomalies, to the cloud. I don't have to worry about serving this or storing this. I'm going to publish this to my ArcGIS online account. So I don't have to worry about any server connections. I just analyze the data, everything is good. And so all I have to do is hit share, and it's going to run the process of publishing this to the cloud. So it usually, depending on the size of your data, it usually just takes a few seconds. Again, this could be features, this could be tiles, this could be rasters, depending on what you need to publish for the particular workflow. So once that's done, we can pop over to the internet and view that web map. For the sake of time, I'm going to show you an example of what you could do with that published data. So I'm going to open an app that my team built that uses published rasters using image server for NASA's GLDAS, the Global Land Data Assimilation System. So this is one of their main hydrologic models for the globe that updates as a reanalysis once a month. It's also available as a forecast. But we're showing the reanalysis project or portion here. So I'm going to click on a point in Turkey, and we can see that we are getting the full time series. So we are querying the pixels of these stored rasters going back from to 2000 to now. We can switch the variable that we're looking at. So we might want to look at from soil moisture to runoff. We can pick somewhere else. We'll go into central Spain, click an area. We could click on this one particular bar if that was an area of interest, and that will change the map display. So with our JavaScript API, there's a lot that you can do to bring more meaning and to your data for somebody who's an expert analyst, but somebody who wants to do some initial querying of the data and some exploration. Of course, we have a lot of templates that can also be used to share data. And so if I publish that NOAA map, I could easily bring that into a template or story map without any coding. I'm not a coder, so this would not be an app that I would build, this particular one, but I've built dozens and dozens of other apps and dashboards. And most of them, they just take a couple minutes of thought and development time before they're ready to publish out to the public. So with that, I think, Jeff, I'm going to turn it back over to you and let you drive this one as we wrap up the presentation.
Yeah, thanks, Dan. And let's go to the questions at first, but I'll just get the closing image up here. As you can see on the screen, we have from our website, for the Weather and Climate Sciences website, a few of the events that are pointed out here. The first one on the left is the Meteorological Technology World Expo, which we're planning to exhibit and have actually this team that you're talking to today or hearing from today, they're supporting that. Hopefully that'll still come off. Following that, we plan to host a workshop in Europe, and we'll be providing information about that. We'll also do our best to put this material, the workshop material, online, so that you can provide, you can have access to the material that we are producing for the workshops. So, please send me your information if you're interested in that workshop. And so I'm going to go ahead and close now. We want to point out again that please visit this Sciences website, which has several resources, including some of the events that are coming up. We hope you can visit us in Paris if the event occurs and you're attending. As well, we host an annual meeting for ocean weather and climate practitioners and our headquarters in California in November. So again, we'd love to see you there if you're able to attend. And then, there's also an active blog area to read some of the product developments, as well as an area to provide us input. We're really want to learn as much as we can about your requirements. And so this is a way to communicate with us about your needs, because we want to continue to improve the products for this space. So we hope you found today's session informative, and our emails are listed at the bottom here of the slide. If you have any questions, feel free to reach out to either Kevin, Dan, or I. And we thank you for your participation, that's a good one, participation today. And thank you again. Bye for now.